All right, so if we have a bank account that is not compounded annually, we would have to use a little bit more complicated of a formula. Still doable though, and it's very much the same as the first one. So let's break this one down. It says let P be the amount invested, so P is still your principal. Same thing here, so whatever you originally put into your account, and an annual interest rate of R, so that's still our rate here, compounded n times per year. So for instance, let's say we had something compounded monthly. Well, that would be 12 months per year, so n here would be 12. And this n is the same as this n, so if you put a 12 here, you got to put a 12 up here too. So that's n times per year, and then let A be the amount after t years. So let's say we kept it in there for 5 years, so t here would still be 5. Notice t and r and p are all in the same spot. The only thing we really added in here was this n here and this n here. So let's see how this guy works. So we'll go ahead again, make sure you write this guy down because you're going to need it for anything that's not compounded annually. All right, example 3, a bank is currently offering a certificate of deposit paying 5.25% interest on compounded quarterly. So quarterly is what we have to pay attention to here. So it's not annually, so we have to use our new formula, which I'll go ahead and jot down here for you, which is A equals, and then we had P, and then times the quantity, 1 plus, then we had R over N to the NT power. All right. So we're going to use that. And quarterly means every quarter, well, a quarter of a dollar, there's 4 quarters in a dollar, so there's 4 quarters in a year. That's what quarter means. So there's 4 quarters in a year, essentially consisting of 3 months apiece. So your first quarter is January through April. Nope, January through March, excuse me. Your second quarter is April through June. Your third quarter is July through September. And then your last quarter is going to be October through December. So that takes us all the way through the year. So 4 times a year we're getting interest. Okay, so find the value of such a CD after 2 years if $1,000 is invested. So here we go. Here's our interest, or our principal rather, the amount we're investing into our account. So that's P. 2 years, that is going to be the time we spent in our CD, so that's T there. Obviously, 5.25 is going to be our rate here. And let's see here. Is that all we need? I guess that's all we need. Yeah, because 4 is our N, which is our number of times per year we're compounding interest. So that's our last number I was looking for there. So let's just go ahead and fill it in. Our amount is going to be P, our principal, was $1,000. So we put $1,000 right here. And then we have our 1 plus is always built in. Now our R here is 5.25. Again, please do not write this as percentage. Change it to a decimal. So we go 2 spots this way. 1, 2. So 0.0525. And a lot of people like to round this and say, ooh, 5.3, or even round it to just 0.05. Please do not do that. As you know, working at a bank, you can't really just guesstimate people's money. They get really angry if you round their money. So you need to use the percentages the way that they are shown there, because it really does end up making a big difference over time. So 0.0525 over N was the number of times per year, remember? So that would be 4. So we divide that by 4. And then to the NT power, so N was 4 again, so NT means N times T, so 4 times 2 power, okay? So now I like to simplify these messy things before I even go to my calculator, so let's do that. So we have A equals 1,000 again, so 1,000 here, and then we have 1 plus this junk. I know it's going to be 1 point something, so let's figure out what that junk is, so I do need my calculator for that. So 0.0525 is our interest rate. I'm just simplifying this fraction here. Divided by 4. Okay. And then I know I'm going to add 1 to that. So plus 1 gives me 1.01. So 0.13125. Okay, now I could choose to write that out or not because I'm gonna just pull it from here. Scoot that over a little bit. 4 times 2 we know is 8, so that's going to be to the 8th power. Okay, so now I know order of operations. I'm going to do this first anyway, so since this is already stored in my calculator, I'm just going to go to the 8th power, and that way it pulls the whole number in case I needed to round for whatever reason. So to the 8th gives me that, but then don't forget we need to multiply that by 1,000, so we say times 1,000. And this is going to be our total money in that account after 2 years. So amount in my account here is $1,109. And let's see, that'll be 95 cents. Whoops, that's a 9, I promise. 95 cents. Boom, there you go. 2 years of doing nothing, you earn $100. Not too shabby. All right, let's take a look at our next example here. Alrighty. Banks are required by law in most states to advertise the effective annual yield, or yield, on every account. The effective annual yield, this is the rate of interest earned after all the compoundings have taken place in 1 year. So essentially, when you have a yield, what you're doing is you're compounding your interest upon interest upon interest. So that what they have to say is, yeah, we compound it more than once a year, but we have to give you the effective annual rate so that you compare it to other banks that only compound once a year. So that is the effective annual yield, is the rate of interest earned after all the compoundings have taken place in 1 year. So that's something you might need to know. So I would put that down if I were you. All right, so yield and interest are kind of the same thing. So find the effective annual yield on an account paying 5.25% interest compounded quarterly. Okay, so we start doing this by using our formula that we just had for compounding quarterly. So remember, we had to use the more complicated of the two formulas. So I'm just going to write that out here for you again. So A equals P times the quantity 1 plus R over N to the NT power. Let's see what we have here, because it doesn't give us a principal. They're not saying we're investing a certain amount of money. And what this bank is saying is, no matter what you invest with us, this is the rate that you're going to get back. So we're actually not going to have a principal. Meaning, we don't know exactly how much money we're going to get out of our account here. So we have neither of those variables. What we do have is we have, well, 1 is just 1, so we have that. We have our rate, which is 5.25, remember written as a decimal though, is 0.0525. 525. We have the number of times we're compounding it a year. It's quarterly, so remember that's 4 times a year. So 4 goes down here. And then we say, all right, 4 still the same 4 as we put down here, so 4 times. Now, how many times a year, or excuse me, 4 times a year, but how many years are we putting in there? Well, if it's an annual yield, that means that there's only going to be 1 year that we're allowed to invest it here. So this would be 4 times 1, which is really just 4. So we could leave that as such. So again, we could figure out what the heck this is over here. So we say, all right, let's simplify. I like to simplify my fractions first. So 0.0525 divided by 4. And order of operations says I have to add that to my 1 first, so plus 1. So we really have 1.01325, excuse me, and we got to take that to the 4th power. So to the 4th power gives us an effective annual yield of 1.053. Let's take it out one more spot, 3.5. Okay, meaning if you invest, now we didn't really put anything in here for our principal, but essentially we've invested $1, let's say. We're going to end up with $1.05 when we're done. Okay, so now if we change this to a percentage, that would be it'd be, well, 105%, but your growth, you already had 100% of what you put in there. So your growth, well, let's change this so you can see here. So 0, 2 places then, so it'd be 105.35%. And it's kind of weird to think, but you already have 100% of what you put in, so you just subtract off 100% from this, just like we subtracted off our original percentages before, or original amounts rather. So if you start to subtract off 100%, you get, well, you would just get 5.35%. okay, because that 100 was there from the original amount that we invested. We just care about the interest, so we take off 100, and 5.35% is their effective annual yield. So EAY. I don't think they call it that, but that's what I'm going to abbreviate it to. So that's your effective annual yield for this particular bank. Alrighty. A bond paying 7% compounded annually. Oh, good. We can go back to the regular equation, which remember, once we know that, we can just write that out. This is the simpler of the two. So A equals P times the quantity, 1 plus, and then we just had R here to the T power. Okay. Still all the same R's, P's, and T's here. So 7% we know is going to be R. So let's just mark that real quick. Anything with a percent is always R. Has matured after 8 years. We know that's going to be T, because that's always time. Giving the owner $10,000. How much was invested 8 years ago? Now you have to be careful with this, because typically when you see the dollars, you're like, oh, that's my principal. That's what I invested. Well, if you read this carefully, it says that it's giving the owner $10,000, meaning that's what's happened after it's matured after 8 years. They want to know how much was invested 8 years ago. That we don't know that. I don't know why you wouldn't know how much you invested, but this guy, I guess, never wrote it down. But he now knows that he has $10,000 in his account. So that means that's the money that he got after all of the interest. So that's what gets put over here. So we take our 10,000 and it actually goes in on this side, which I know seems weird at first, but we can handle this. It's just an equation we got to solve. So that equals, we still don't know P, so P's got to stay. And then 1 plus, we know our R, we've already decided it's 7% or 0.07. 0.07. And then T, we already know is 8. Okay, so let's simplify and see what we can do here. Alrighty. So, well, that's silly. We can simplify this real quick. So 10,000 equals P times 1.07 to the 8th power. Alrighty. And now we can grab our calculator over here, because I do not know what 1.07 to the 8th power is off the top of my head. I'd be impressed if you do. Okay, so that's what we're dealing with here. I'm not even going to bother writing that down, because I know I'm going to divide by whatever number that is on each side. So 1.71, blah, blah, blah. So I'm going to divide by those numbers. So I'm going to do 10,000 divided by that. Well, I don't even need to write it down, because 10,000, this calculator is so nice. 1, 2, 3, 4. I just like to double check. Divided by, let's pull the answer, and then I don't have to worry about rounding or anything as such. So we divide it by, well, this 1.7 to the 8th power. So we say enter. And our principal then, because these cancel out, these are going to cancel right here. And then whatever number we get here is going to be our principal, which is what's left over. So our principal, or the amount we originally invested, should be less than what we started with, because you earn interest. So we invested less than we end up with. If it's going the other way around, then you might want to check your bond out, because that's not the way it's supposed to work. But at any rate, we have $5,820 and 9 cents, it appears. 9 cents. So wow, it's almost doubled in the 8 years that we left it in there. Pretty impressive. So $5,820.09 is what was originally invested. And it appears that was the last example. So now you should be ready to do the worksheets that we're going to be doing in class tomorrow. Please remember both of those formulas. They're very, very important. I hope you wrote them down. See you tomorrow.